So if we were to put this into a loop, shifting each time through the loop, and just examine what's in $1, if we loop around until there's nothing left on the command line, we will examine, in order, everything on the command line. Let's go ahead and turn this into a loop. We can begin by displaying our situation just like we did before. But instead of shifting individually, we're going to use a loop. This loop should run as long as there's anything left on the command line to work on, until we have shifted it all away. A while loop will be sufficient for this, and the test we are interested in is whether or not the number sign variable is still greater than 0. Is there anything left on the command line? As long as there is, we want to tell it to do some commands. And the commands we'll do is we'll tell it that we're going to shift. We're going to do the shift. We'll print out what's left. And that will be the end of our loop. So each time through the loop, we'll shift it over by 1 and show what's left. We'll keep doing that until there's nothing left, until the count goes to 0. Let's try that and see what happens. And if we scroll back to where the command ran, we can see we began with 4 arguments, A, B, C, and D. We shifted, which took us to 3 arguments, B, C, D, and 4 is now empty. We shifted and had 2 arguments left, just the C and the D. We shifted, now we have just the D. We shifted, and now we have nothing left. And of course the loop finishes. So let's make this a little easier to read the output of, since we know that every argument on the command line will wind up passing through the number 1 variable. Let's just display the number 1 variable. Also, once the loop is done, rather than having it end mysteriously, let's print out what we did, that we processed everything on the command line. Now our processing is very trivial. All we're doing is displaying it, but that's okay. Let's save this and see what our compacted output looks like. Gee, it looks like we broke things, but we didn't. Did you notice? There was nothing on the command line, so there was nothing to shift. Now if we run it with some things on the command line, we can put as many as we wish, and each one should wind up being shifted through. When we received the command, we had 5 things, and A was in $1. We shifted, and now B was in $1 with only 4 things left, then C, D, E, until we were done. Note that if we were going to process or actually do something with the items, we would want to do that before we shift. After we've shifted, the thing that was in 1 is gone, and we cannot process it. Note that when we get to 0, we really don't want to print what's in 1 because there's nothing there. So let's go ahead and modify this, instead of just printing them, to recognize what's there and see if it matches anything we were expecting on the command line. We no longer need to print out all the arguments, or their count, or even the command name itself. We already see how that works. So let's get rid of this command. Instead, let's just tell the user we're going to process the command line so that they know what's going on in the script. Normally, you wouldn't do this in a real script. We're doing it so we can see what's happening. Once we get into the script, before we do our shift, we'd like to see what's in $1 and do something, if necessary, with that. We said we were going to look to see if we had any recognized patterns. We already know a good command for recognizing patterns, the case command. The variable we're looking at for the data is $1. When we are looking for a number of patterns, the first pattern we'll say is if the user put in -h or $help as an option, thinking they're asking for us to give them help on how to use the command. If they've asked for the help, we can go ahead and process this. In other words, we can act on it. We can do what needs to be done, because if they've asked for help, there's no other work for our script to do besides giving them the help. Giving them the help means printing it on the screen. Let's go ahead and just echo out some help for using the command. We don't need to know our command name to put in. We can tell them the command was whatever was in 0, and that optionally they can specify -h or $help. The square brackets are used in syntax diagrams or command line help to tell the user this is an optional thing to put on the command line. -h with the pipe, $help means the user can enter -h or they can enter $help, and that all of that is completely optional. We've done everything the user wants us to do. There's nothing else for the script to do, so there's no point in continuing past the while loop. We can just exit our script if they gave us the request for help. In this case, we have completely processed that command line argument. Another command line argument we might allow them to give us might be -d, meaning put our script into debugging mode. That's the only pattern we'll allow for that. And when we go into debugging mode, it means that as the script runs, we would like to print out extra information to them about what's going on in our script. We can't actually take this action until we are further in the script and doing things. So processing this command line argument means somehow saving that we were given this argument. In this case, let's set a variable called debug, and let's set it to the word yes to say it was turned on. And that's the only thing we need to do with that one. Later in the script, we can test that variable to see if we should be doing things in a debugging mode. If we're going to do this, we should have a default value for the debug, probably set to no in this case. And we should set that before we look at the command line. That way, if the user does not give the -d option, debug variable will be set to no. And if they do give it, it will be set to yes. Note that since we have improved our command to recognize an extra option, we should update our command line help to say there's an extra option that they could choose to give us, the -D. And since we don't require it, we'll put it in square brackets to tell the user that's optional. That's enough for right now to demonstrate what we're trying to do. The only thing we need to do still is finish our case statement. Then shift our command line to move the next item into $1. And we no longer need to be printing out everything that's going on as we shift around. We'll leave it there for the moment for test purposes. Since we may have set a variable as part of our command line processing, it might be helpful for our understanding to indicate whether or not that variable got set, and if so, what it got set to. So we can simply print that out. This has changed quite a bit from the previous version. Let's quickly review what we did. We said that we are going to process our command line. So we'll tell the user we're going to do it. We'll do it in this while loop, and then we'll tell them it got done and what the result was. We allow the user to give us a help request on the command line or a debugging request. In the case of the help request, we print out a statement telling them help for how to use our command and quit. If they ask us for help, we aren't going to do anything else in our script. We're just going to display the help. If they give us the debug option, we'll change the value of a debug variable to yes from its default value of no. And since we're being verbose right now, we'll tell them we're processing the command line, when we're shifting, what's left to process. Let's save this and try it.